video then we were still looking at the savings amount. We were just moving on to the last question in the savings one, and it was the 2013 paper one. So let's continue from here. So let's take a look at question A there. It says Neve has saved to buy a car. She saves an equal amount at the beginning of each month in an account that earned an AER, an annual equivalent rate, of 4%. Part 1, now we'll always get a part 1 like this, it's just a nice kind of handy start to it. It's saying show the interest rate compound monthly, which is equivalent to an AER of 4%, is 0.327, corrected 3 decimal places. What they're looking for you to do there is they're looking to find the AER in terms of months. So all you're doing is you're taking your 4%, so your AER of 4%, you have 1.04, you put it at the power of 1/12 because we're trying to change it into months. We get this value here because they're looking for it to be an interest rate. This is where we minus 1 multiply by 100. And you should get this value here. So that's the first one. This is the point where we minus the 1 and we multiply by 100. Otherwise, we keep this value here. And that's the value that we will be using in the second part of this question. So this part here is just for part 1. Otherwise, you don't use it, you use this one here. Because this is the percentage, this is it as an interest or as a decimal. So your interest rate is the decimal. Part 2 of this question then says, Neve has 15,000 in an account at the end of 36 months. How much has she saved each month? So again, months. Step 1 was change everything into months. We have our time in months. We have our interest in months. So we've done our step 1. Step 2, we need to write out the pattern. Now, we know that this is what she has in the account at the end. That is the F value. That's the final amount. We don't know what she's saving each month, so we do know she's saving the same amount, so we're going to call that unknown P. We'll keep it as the P value. We're using F equals P by 1 plus I to the power of T, and this is what's happening over and over again to get one final amount. So I write in my pattern, I have my 15,000 equals, I have my P value, that one I don't know. I have my interest, the one that's from up here. And then I have my power of 36, power of 35, so on and so forth. Just another thing to notice here, I haven't used all of this figure here. Now the reason why is because if in the question above they give you this one, you don't have to use that. You can just use the bit that they want you to use, the 0.0327. But it's up to yourself. If you use the whole thing, that would be okay as well. So again, I'm using my SN formula here. And with my SN formula, I'm picking out my A, which is this. I'm picking out my OR, which is either going to be the 1 over 1.00327 or 1.00327. Because this is not a fraction, the OR value is going to be a fraction. And my N value, how many times does this happen? It happens 36 times. Substituting everything in, letting it equal the 15,000 that I know it should equal. And we are going to put this whole bit here into the calculator. And it comes out as this. Now, if you used this value, you might get something slightly different, but nothing too different. Okay, once I get this in the calculator, I bring it across and I divide by it, and I end up with the value of, because they said correct to the nearest euro, I'm keeping it as the value of 392. So either this or using this one will get you that value. Okay, so moving on then from that, we're going to take a look now at amortization. So amortization is just a fancy word for a loan. It allows you to find the repayments for a loan. So for this first question here, amortization is used for mortgages and loans. This formula here is in the log tables, and it's a formula that you can use. O represents the repayment amount, A is the loan amount, I is the interest rate, and T is the time. So when I go to use that, I have this example here. A loan of 350,000 is taken out over 20 years at an APR of 2.5%. Find the monthly repayment. So step 1 was always make sure everything is in the same, if it's either years, months, or whatever. If they're looking for the monthly repayment, I need to change everything to be months. So this is changed to be months, this is changed to be months. Out in the side here in the box, I have, this is my now interest rate, and this is my months. And all we're doing is we're filling in this. We're looking for how much the monthly repayment is. So I'm looking for the OR value. 350 goes in. I put in my interest value. So the interest value without the 1, because that's the I value. The 1 plus the I is the whole amount. The power of 240 is just the time, all over 1 plus my interest again to the power of 240 minus 1. And I get this value here. Nice kind of handy question to use. The only problem with this question is if they don't say you can use this formula, it makes it much easier. However, they can ask you to use a geometric pattern. So the geometric pattern is what we were doing before, using the SN formula. So if we look at this question again, same question as above, we should be getting the exact same answer. We are now going to do it using a geometric pattern. So we're going to do it using F equals P by 1 plus I to the power of T. So for this one here, a loan of 350,000 is taken out over 20 years at an APR of 2.5%. Find the monthly repayment. Now, same as before, I just have over in the box here that we're doing this into month, or changing this into months and this into months, and then the APR into monthly as well. Now we have to be careful with this because this formula here is what we use. The other formula that we have found is P is equal to F over 1 plus I to the power of T. So there are two formulas that we can use. We've always just been using this one for savings, which is fine. However, we don't always use that one. We can sometimes use this one here. Now, the difference between them is what we have to figure out is where is the lump sum? Where is the large amount of money? And that's the one that goes on the left. And the one on the right then is what repeats over and over again. So when we were looking at the savings questions, we were getting a large final amount from anything we were saving. So that was the one on the left, the large final amount. And then these ones here, what happens over and over and over again. Whereas in this question here, a loan of 350 is taken out. That means that I have 350,000. When do I have it? I have it at the start, which means I have a really large present value or a large amount now. So this is what has to happen over and over and over again. So that's how you figure out which one of these formulas that you're using. So if I look at this question here, I can see that this is the value that I'm using. I have 350 is a large amount. I'm putting that on the left-hand side because it's one single large amount. And then I'm using F is the value that I don't know, all over 1 plus my interest to the power of time of 240. So the interest value again is coming from there a minute ago when we got it, and the time again is coming from a minute ago when we got it using these two parts here. So I fill out my pattern, and again I use my SN formula. I need to pick out A, I need to pick out OR. A is going to be the first one, and remember we were saying earlier if one of them is a fraction, the other one isn't. So if that's my fraction, if A is the fraction, then my OR value is going to just be the interest, no fraction. N then stays as 240. Subbing everything into the formula, this one here. And what we're going to do here, this is where it gets a little bit tricky because the F is stuck on top. What you're going to do is you're going to make that a 1 and you're going to put your F out the front. And we're going to put this whole thing into the calculator. Let's just take the F out as common really and change it to be a 1. When you put that in the calculator, you get this value here. I bring it across then and I divide and I end up with this 184986, which is the same as the answer from above. Okay. Let's take a look then at the last one here. So this is from, again, the 2013 paper 1. We just did, in the previous video, we did one about Neve. She was the part 1 of that question. This is the part 2. So here we have Connell borrowed to buy a car. He borrowed 15,000 at a monthly interest rate. They've given us the monthly interest rate. He makes 36 equal monthly repayments. How much to the near zero was each of the monthly repayments? So because they haven't said I have to use a geometric pattern, I can use the formula from above. My A value is going to be 15,000. My interest value is going to be the 0.00866, and my time is 36 months. And I fill in my formula into the calculator. It goes. If I wanted to use the pattern formula, the geometric pattern formula, what I could do here is I know that I have a large. So if I'm using these two formulas, Okay, they're my two options for formulas. I have borrowed 15,000, or Connell has borrowed 15,000. That's a large amount that he has at the start. So if I have a large amount at the start, it's the large amount goes on the left-hand side. So I have to use this formula here. So I have 15,000 from my P value is equal to F, I don't know, that's the amount that I'm giving back each time. 1 plus my interest is 1.00866 to the power of 36. The next one then would be F over 1.00866 to the power of 35, so on and so forth. So for that then, my A value for my SN formula is the first one, to the power of 36. My OR value, because my A is a fraction, means that this is not a fraction. Okay, and my N value is the 36 times. So that means that for my SN formula, I'll write the SN formula up here. A by 1 minus OR to the power of N, all over 1 minus OR. I'm going to fill that in. The SN is 15,000. My answer is going to be 15,000 equals A, which is F over 0.0866 to the power of 36, that's A, by 1 minus 1 OR, which is 1.00866. I realized I forgot a 0 in here. How many times this happened? 36 times, all over 1 minus 1.00866. Again, what I'm doing here then to sub into the calculator, changing this to be a 1, taking out my F is common. All of this goes into the calculator, and I end up then dividing my 15,000 by that answer, and I still get the 486.77 euro. Okay, so either way you should be getting that answer.